We are going to prove that there is an infinity of prime number. So a prime number is a number that can be divided only by itself or by 1. So example of prime number are 2, 3, 5, 7, 11, 13, etc. So we see that there is a quite number of prime numbers. So how do we prove that there is an infinity of prime number? We are going to prove it by contradiction. So we are going to assume that there is only a finite number of prime number, and we are going to prove that there is something that goes wrong in the proof. So for example, let's call the first prime number P1, so it's 2, and then P2 is 3, etc. So there is an infinite number of prime number. We are going to assume that there is a finite number of prime number, and we are going to call the last one Pn. So we don't know what this number is, but probably a very large number. And we are going to consider a new number x, which is equal to P1 times P2 times, that is a product of all the prime number, so Pn, and we are going to add to this number 1. Okay, so this number x is a number that is bigger than all the prime numbers, and actually x by construction cannot be divided by P1 or P2 or Pn, because when we divide x by one of these prime numbers, the remaining of the division is 1. So we can make two conclusions of that. So either x so cannot be divided by any of these prime number. So either x is a prime number, or there exists, if it's not a prime number, it means that there exists a prime number that I'm going to call P, that is greater than any of all the prime number P1, Pn. That is greater than Pn. So we can see that these two show that there is a contradiction. These two are not possible. So it means that our assumption at the beginning is wrong. So it means that there is not a finite number of prime number, and this is a method to build a prime number from any other prime number that we know. So if we know P1, P2, Pn, then x, we can build another prime number just by multiplying all this number and adding 1.